Okay, so
Oh man.
so let's again take it a piece at a time. All right. So if we look at the left-hand side here, when we go to take the derivative of this left-hand side, what are we going to have to use? Product rule. We have something times something, something with a variable times something with a variable. So there's our like first piece. There's like our second piece. Okay, we break it up. So again, for the way I do product rule, I always do the first. So 2 sine w times the derivative of the second. Okay, so the derivative of cosine is negative sine of t times the derivative of what's inside. What is the derivative of t with respect to t? It's just going to be 1. Just 1. It's like dt, dt. dt, dt, so it's just 1. Plus the second thing, so now cosine t, times the derivative of the first thing. So derivative of 2 sine of something to cosine of that same something times the derivative of what's inside. What is the derivative of w with respect to time? Those variables don't line up, right? The derivative of t with respect to t, I shouldn't say with respect to time because it might not be time here. The derivative of t with respect to t, those variables line up, they match up. So we just do the derivative like you kind of like quote unquote normally would, and so derivative of t is just 1. Here though, when we go to do the derivative of what's inside, the derivative of w with respect to t, those derivatives do not, those variables don't line up, and so we just multiply it by dw dt. Okay, and then that's the left-hand side. So questions on that? Questions on that? Okay, just gonna if you like call that f and g, then this is f times g prime plus g times f prime. Okay, if you want to think of it like that way. All right, equals the derivative of pi squared. So the derivative of pi squared is 2 pi to the 1 times d pi.
Good job, Mr.
No.
It works.
What are you talking like that?
Actually, it is still. That is still true.
It's 0. Okay. This derivative is 0. Okay, we're all okay with that. Derivative of pi squared is 0 because pi squared is a constant. It's a number. Pi is not a variable. It's a number, right, in math. So pi squared, derivative of that is 0. Okay. So good. Good. Now, we want to solve for dw dt. That means we got to get this thing here by itself. We have to eliminate everything else. So let me see if I can maybe simplify this just a little bit here. So we let negative 2 sine w times sine t plus... I put the negative with it too. And then 2 cosine t cosine w times dw dt. Question? Okay. All right. So our next step, I guess I should say, let me get my... Calling someone here. All right, so Maya, what should be our next step here to solve this equation for dw dt? Right, okay, so to start doing that, so there's the thing we want to solve for, right? That's what we want to get by itself. So what should we get rid of first here, maybe? And we're going to get rid of it by doing what to both sides here? Yeah, that's exactly right, adding. So we got 2 cosine t cosine w dw dt equals then 2 sine w sine t. So we added both sides, very good. Okay, and then next up there, Maya, after that?
No.
Divide both sides by what? Yeah, that's right. So then makes 2 sine W sine T all over 2 cosine T cosine W.
Negative sign.
Should have had a.
Sorry.
You should have had a cosine T on your.
Something happened to me in recent years where I write my W's very lazily like that. I don't know why.
Oh.
I used to write them normally, but now I can't. It's really like if I'm writing quickly, I'm like that's a W to me. Oh, you can't see it. That's a W to me. I know, because when I write it so quick, I have to if I really want to write it correctly, I have to take my time when I write it to make a W.
Right, Mr. Wynn.
Upside down N.
Oh, that's true. I should maybe start doing that.
Probably.
So, and then my signature is a hot mess right now because so many passes I have to sign. It's just like, there's my signature. when I do bathroom passes, people are like, who is that? All right. Anyway, so there's that. Now, is that it?
No.
We can actually simplify this some more. So, like for example, the 2's they cancel.
But wait, there's more.
And right, so Caleb, we have tangents here, don't we? So it's not sine W over cosine T that would make tangent, but we have sine W over cosine W right there, which makes a tangent W. And then sine of T over cosine T also makes a tangent T.
True.
And so that would be your final answer right there. A nice, neat little package.
That was very satisfying.
Good. No, it would not be. No, of course not. If you left it as this, that's fine. Just understand, right, on a multiple choice, there's a good chance it would look like that. So you need to make sure that you can see that, yes, there is further simplification you can do.
I get a lot of these mixed up, my T's with plus signs. So would it be, do I have to say let lowercase t be, can I just change it to big T?
I just give it a tick.
Say that one more time.
Okay, so I want to change it to a big T, so I don't get it messed up.
Capital T.
Yeah.
Well, put a little tail on it like I do. I think it's okay for you to use just a capital T instead. I think that's you don't need to put the let thing. But if you change the actual letter or something, like if you make it thetas instead of T's or something, that could be kind of deal. Yeah. All right. So we're okay with that. Any questions there? That again is more just an exercise in being able to take the derivative without there being x's and y's in there. So the key thing you want to remember, especially in situations like this where we're not using the x's and y's, when you're taking the derivative with respect to t in this case, when you take the derivative of something that's not lining up with the t here. So for example, we take the derivative of w with respect to t, that's where you leave the dw dt, right? But here when we take the derivative of t, it's with respect to t, and so that's when you just take the derivative as you normally would. You don't have to worry about the dw dt's or anything like that. Okay, so that's the key there to take away. This thing is kind of like telling, it's the key to how you would take the derivative, right? If it matches, if the variables match, you take the derivative kind of like as you normally would. If the derivatives, so like there. If the derivatives don't match, so like these two don't match, these two do match. So these two you just take the derivative like you normally would. This one, they don't match, so that's why you have to have the dw dt there. Okay, so that's the takeaway. All right, we're going to do two more here. And it's going to be very fun. So I had a question yesterday from Donovan in Flex, and his question was, Mr. Widd, these are too easy. Can you make them a little bit harder for me?
Oh, thanks, Donovan.
That wasn't a question, Donovan, I said. And he said, Mr. Widd, you're the one that said that, and he's right. And now I'm making things up. All right. But he did seriously have a question, and it was this question: can we take the second derivative of these things? And yes, Donovan, we can. And then I proceeded to show him how to do the second derivative, and he started to cry. He didn't start to cry, but he was not happy with it. Now I'm lying again. Sorry, I just can't help myself. Okay, I'm lying again. I can't help myself. I just choose not to. Okay. I know, right? It's too much.
I wonder what I got.
I kind of feel like that one SNL character that, oh shoot, I can't remember her name now. She would do, or she's like, just kidding, I did this. Oh, just kidding, I did this. Anyway, you guys, no one knows what I'm talking about. Yeah, Kristen Wiig's character, where she was like, just kidding, I'm this way. No, just kidding, I'm this way. And then it'd be like a whole sketch full of that. So anyway, taking the derivative of this thing with respect to x. So in order to find the second derivative, we first have to do the first derivative. That's right. So the derivative of this is 2x plus 2y dy dx equals 0. Okay, again, the derivative of x squared with respect to x, 2x. They match up, they line up, so we can just take the normal derivative. Derivative of y squared with respect to x is 2y dy dx, and then equals 0.
Negative x.
Okay, so now, Drew, at this point, we want to get the dy dx by itself, so how would I go about doing that? Yep, so we get 2y dy dx equals negative 2x. And then divide the sides by 2y, so you get dy dx equals negative 2x over 2y, which then is really just negative x over y. Okay. Oh, by the way, the directions here should probably be find d squared y dx squared in terms of x and y. And I'll explain why those are important directions in a second.
You have to isolate dy dx before you find the second derivative, or does it not?
No, you don't have to. You don't have to. So if you guys didn't hear Caleb's question here real quick, I think it's a good thing to highlight real quick. Caleb's question was, if we're trying to find the second derivative here, do we have to isolate dy dx first and then take the second derivative, or can we just take the derivative of this thing again and just continue on from there? And you can. You could just take the derivative of this thing. It would require you to use a product rule right here, right, when you take the derivative of 2y dy dx. So that's one option. Alternatively, we can take the derivative this way at this point as well, too. So let's do it here. Since we're here, we'll go from here. Okay. So what's the derivative of dy dx with respect to x?
dy squared dx.
Yeah, it's the d squared y over dx squared. So the left-hand side's easy. The right-hand side, when we go to take that derivative, we got to use, that's right, we got to use a quotient rule. So Nate, can you help me out there? What's the derivative of negative x over y going to be using the quotient rule there? Sure. Okay, so the bottom times the derivative of the top, so yep, y times negative 1 minus.
Actually, the plus is greater.
So yeah, I'm gonna leave the minus, but I see what you're saying. So I'll leave it minus a negative x. Okay. Times dy dx all over y squared. And yes, and so Nate was right there. We can simplify this sum, so we get negative y plus x dy dx over y squared, like so. Okay. So there it is. Have we found d squared y dx squared in terms of x and y? So those of you saying no, why not?
Oh, because you wanted to.
So is it in terms of just x and y?
No.
What else is in there?
Y.
We have a derivative. So this is not quite finished yet because we have the second derivative. So right, we could say, okay, there is a second derivative. We've taken it. But we haven't finished answering the question because the question says we want the derivative, the second derivative, in terms of x and y, and it does not say we can have it in terms of the first derivative here. So what the heck are we supposed to do with this? What is this?
Is that not just one?
dy dx? It's not just one.
No, here.
Yeah. What is dy dx?
Wait, dy dx is negative x over y.
That's right, it's this! Is that what you're going to say, Brittany? Yep, exactly right.
My goodness.
It's that. So we just plug that in. So it's negative y plus x times negative x over y all over y squared.
Yeah,
Now it is in terms of x and y alone. Okay. So that's it.
What was it simplified to?
Whoa, what would I simplify to? All right,
I
well...
feel like if you do it, I feel like if you end up doing
Max like, no more, mercy.
If you do this like a product roll method, I think you get it down.
It might be easier to simplify,
Yeah.
yeah. Let's see, did I? I did, actually. So I'm going to do it. You guys can just follow along if you want to. You don't have to do it if you don't want to, but I am going to go ahead and put this all together so we don't have fractions within fractions. Again, we should be comfortable with manipulating things so we don't end up with fractions within fractions like that. So, real quick, I can see here I'm going to have a denominator of y, so I want to make this thing a denominator of y, so I'll make it negative y squared over y. Yes, negative y squared, because I'm going to multiply this by y over y here, and that's going to make negative y squared over y, plus negative x squared over y, all over y squared. And then that becomes negative y squared plus, well, whatever, negative x squared. So I combine the fractions together. And then negative y squared plus negative x squared over y to the third, then, is what that would be. Okay, instead of dividing by y squared, you can multiply 1 over y squared, and that makes that. That looks kind of nicer now. Okay. Oh, but wait, there's more. I forgot, yeah.
What is it? Oh my.
I will show you. All right, so what can I still further do to this numerator here? Factor out a negative 1. We could take the derivative, but this is, I'm just talking simplification's sake. Okay? And like, there's still one more step here. What is x squared plus y squared equal to in this problem?
25.
25.
Oh my goodness.
That is crazy.
There it is. That's really it.
I'm like, what? See, if that was a multiple choice answer,
You'd be like,
No.
no way, no way. Oh, scratch that one out. There is no way that's the answer. Yeah, it is. It is the answer.
So that would be the answer.
Yeah.
On a multiple choice test.
Possibly.
Would you be that cruel to us?
I would like to think no, but the book though, I got this from the book. I'm pretty sure. So I just wanted to show you to what degree. Now, will I expect you to plug in for dy dx?
Yes.
Yes. You need to be able to plug in for dy dx. Absolutely.
Like on your quiz slash test, if you like leave it, where we just plug it in.
If it's not multiple choice, yeah, you're done right there. You're done right there.
But on the multiple choice.
Multiple choice, you got to match whatever you got there.
Do you do it though? Like,
I don't think, nah, that's a bit much, but to hear, maybe. Yeah, to hear at least. No, they won't all work out like that. Yeah, this is just a very, kind of nice kind of problem. Nice. You guys might think that was not very nice. I understand. That's right. Okay. Last one we'll do here. And you don't, like, these, when you do the second derivatives, they're normally not too,
My last
like,
page
complicated.
Wow.
Wow.
You
And we're only a fourth of the way through the class.
So were you gonna teach us this, or were you actually just being dumb?
Say it one more time. Oh, I am not. Yeah, I'm not just humoring Donovan's question. This is the next topic we're going to learn today. So Donovan was just like looking into the future using his prophetic abilities. Yeah, the powers of Donovan.
In terms of X and Y or not?
He is the key to the future.
Oh my God.
To unlock the future. So, did you have an actual question for me?
Yeah.
What was it?
So is this in terms of X and Y or not?
So, yes, in terms of X and Y. Sorry, I think I should. If it doesn't say, I wouldn't worry about that. But I think in general, yes, you're going to be plugging in for dy dx. In general, you're going to be plugging in for the dy dx, yes. All right, I'm going to pick somebody here. All right, so Christian, you want to help me take this derivative here, the first derivative?
It's gonna be 2x
2x
plus.
plus.
And we have to do product.
Okay, very good, guys. This is a product rule here. xy, right? It looks so simple. It looks so easy. We just want to say, oh, it's 1 dy dx. It's not just 1 dy dx here. It's a product, so we have to use product rule. Yeah, bless you. Okay, so, Christian, take it away then.
It'll be x.
So, okay. Y prime or dy dx, I guess. Which one do you like to use?
dy dx.
All right, we'll use dy dx.
And minus.
Whoop. Plus.
Oh. Yeah, never mind.
Right, okay.
Confused.
Yeah.
Y times 1.
1. So I'm going to just leave it as y then. And then equals?
0.
Very good. Okay, so a couple things to point out here. First thing, be very careful here. Please make sure, don't forget to take the derivative of that right-hand side. Students sometimes forget to take the derivative of 5 and make it 0 here, which messes up their whole derivative then because they forget that. Also, be very careful with this. I know right here it's a plus sign, so if you didn't put parentheses around this product rule, it's not going to like screw you because it's a plus sign, so it, the distribute. But if this were a minus sign, if this were x squared minus xy, the minus would have to distribute to both terms here. Okay? So please, on like a future quiz or test, put parentheses when you're doing that product rule inside of, and when you're doing like the implicit differentiation there, because that minus sign needs to distribute. Students will miss that, and then it messes everything up. I'm pretty sure, I know it's going to show up in a future quiz or test. I know that for a fact, okay? So please, 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 if you have like just whenever you're doing your derivatives here, like a product rule, put a little parentheses around it so that way you know you have to distribute that sign. Okay. So anywho, thank you, Chris, for the first derivative there. All right, Brendan. So you could take the second derivative at this point, or you could isolate the dy dx and then take the second derivative. So yeah, it's up to you. So go ahead. What do you want to do? Subtract 2x from both sides. So you get x dy dx plus y equals negative 2x. Subtract the y from both sides. X dy dx equals negative 2x minus y. Divide by x. Negative 2x minus y over x, like so. Okay, so there's your first derivative in terms of x and y. All right.
You got a final answer. I got it.
Mac. Okay, second derivative here, please. So the left-hand side. Well, give me the left-hand side first, real quick. Sorry. Okay, great. Equals. Okay, so now it's going to be, what rule do we have to use here? Quotient rule. Okay. It's G on the, yeah. Times negative 2. Well, the derivative of y with respect to x is minus dy dx. Right? So minus dy dx. So it would be negative 2 minus dy dx. So it's, yeah, it's the bottom times the derivative of the top, so there's that. Okay. Minus now, okay. Uh-huh. Yeah, just times the derivative. So again, this is the derivative of x with respect to x, so it's just a normal 1. Yeah, it's just taking the normal derivative all over. Perfect. Yes. Good. That's it.
Oh man, I got this.
All right, so I'm going to do some simplification here first before we worry about this. So the x I'm going to distribute to the negative 2 and to the dy dx. This minus will also distribute to the negative 2x and the negative y, so we get negative 2x minus x dy dx, I should say, plus 2x plus y, all over x squared. Ooh, something simplifies here, doesn't it?
Yeah. Like terms.
Yeah, so we have some like terms that we can cancel. So what are the like terms here, Austin?
Negative 2x and positive 2x.
Yeah, we have a negative 2x and a positive 2x that cancel, so that's nice. And so we have negative x dy over dx plus y all over x squared. And let's see here, what is dy dx?
Negative 2x minus y over x.
guy up here. So that's just negative x times negative 2x minus y over x plus y all over x squared. So he could stop there. Bernie's like, I'm stopping there. And you can stop there if you want. But this does simplify, and it's not too bad in the simplification, right? For example, the x and the x here are going to cancel. And then that minus 1 now will distribute to the negative 2x and the negative y, and make it positive 2x plus y plus another y all over x squared.
Scoot down a little bit.
Oh, sorry, is it out of the... And so we get 2x plus 2y all over x squared.
Will it ever ask us to solve just in terms of x? Like to solve for example?
No, I don't
x
think
plus
so.
y?
I don't think you'd have to worry about that, no.
We could do that, right?
Yeah, if you wanted to, you could solve, yeah, you could, like, back up here, the
Yeah.
original, you could solve one for, like, the y to the x. Well, you could solve for y.
We could solve it for x plus y, if you factor out the 2. Because
Yeah.
you can factor out an x on the top and have x on the
Now, we actually did not have to use implicit differentiation here.
with
You guys see?
Guesstimations.
Right, so we could have alternatively here,
that's cool. I keep thinking your y's are 4s.
I'm sorry, yes, my bad handwriting.
I keep going like, there are 4 then. Yeah, I was like, what?
How can we do this without implicit differentiation? What do we need to do here? What can we do first? Subtract x squared from both sides. And then what? Divide both sides by x. You want to get the x or the y by itself here.
Should have seen that. See, once you're so stuck in like, yeah.
I understand, yeah, but now I'm showing it to you. Now I'm showing it to you.
That would have been.
And plus we are trying to, we were in implicit differentiation, so we wanted to use it to get the practice. So to take the derivative here, we have to use the quotient rule, right? So it's y prime equals, let's see here, the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared.
And then look, it's the same thing we had.
Let's see here, negative 2x squared minus 5 plus x squared all over x squared, which is negative x squared minus 5 all over x squared. And then we take the derivative again, so it'll be the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Let's see, plus 2x to the third plus 10x all over x to the fourth, so those cancel. I get 10x over x to the fourth, which is then just 10 over x cubed. Huh.
Not the same thing.
It is not the same thing, but this has some y's in it, so I would imagine if I took this y and plugged it in for the y there and simplified, I would imagine we end up with that then, maybe.
Let's find out.
So that's what I simplified to there.
Probably look like the exact same thing.
Well, but it's hard to, you can't graph, y. Actually, no, no, we can't. So. I forgot. Sometimes there are ways we can do it, but I know. I was trying to think. Sometimes we can, but not in this case, I don't think. Yeah, no. Okay, so anyway. So, two different answers there. This is in terms of x and y, though, so we're fine with that. And then that, if we actually were to plug in this y here, I think it would simplify. I'll actually try that and see if it does work there, but it should. All right, so more importantly, though, questions on taking that second derivative. Okay? Any questions on that? The key is you don't want to stop at just dy dx. You want to plug back in that old first derivative and for the dy dx there. Okay, and then simplify, obviously, best you can. All right, so that's it. We're going to get you guys started on your homework then, okay?
Whoa.